So I am officially recording, and this video is to help us prepare for the Chapter 9 test. And I do apologize, I did write down things quickly as opposed to typing them, so I apologize for my ugly handwriting. Anyway, let's begin. You need to know standard form, right? You see, Chapter 9 is all about graphing quadratics, or about quadratic equations themselves, and we know how to graph parabolas that are in standard form. Ax squared plus bx plus c. A, b, and c are just numbers. The a value tells you a lot about the parabola. It tells you whether it opens up, whether it opens down, gets reflected over the x-axis, right? It also tells you if it's a vertical stretch or a vertical compression when you talk about the transformations. But we'll get to transformations later. Right now, we need to know that this is standard form, and we also need to know how to start graphing it, how to find the vertex. How do you find the vertex? X equals negative b over 2 times a. And like always, whenever you use a formula or whenever you're plugging in values, I recommend using parentheses as you plug them in. That way you don't make mistakes. So when you use this vertex formula, it'll give you the x value of your vertex, and you simply plug in whatever that answer is into your x's right there, and then you'll be able to do the math and you'll get the y value of your vertex, right? It is a lot easier to state your vertex when your equation is in vertex form. Y equals a times x minus h, close parentheses, squared plus k. Really awesome when it's in vertex form. I love vertex form. It's way faster, way easier than standard form. Notice that both a's are in blue. That's because the a is the number that's out in front. It tells you the same thing. If it's positive, it's opening up. If it's negative, it's opening down. If the a value is further away from like 0, bigger than 1, like let's say a is 1, a is 2, a is 3, it's starting to get vertically stretched away from the x-axis. If the a value is a fraction that's closer to 0, then it's a vertical compression towards the x-axis, which makes the parabola wider. Again, we'll review transformations in a little bit. Right now, I just wanted to go over the two forms, standard form and vertex form. And knowing these forms, I could ask you so many different things about one equation. Check it out. Right here, I'm asking you to state the range, right? Now, we should all know that the domain of any parabola is x equals all real numbers because it goes to the left forever and it goes to the right forever. But if I ask you to state the range are your y values. Okay, and to really understand or to really explain this question, let's get a quick sketch of what this looks like. Well, we know that the vertex form gives us the vertex, h and k, and all we have to do is think opposite of what we see on h. So the vertex, I see a positive 2, that means that the x value is a negative 2. And the k value is a minus 1, you take that for what it is. So the vertex truly is negative 2, negative 1. By the way, that could be a question I ask. Instead of state the range, I could simply say, what is the vertex? This would be your answer, negative 2, comma, negative 1. I think there is a question like that. And you type it in with parentheses, no spaces between your terms, close parentheses, if I ask you for the vertex. All right, anyway, let's do a quick sketch. Here's our xy plane. Sorry, it's kind of crooked, I apologize. Let's go to negative 2 and then negative 1. And here is our vertex. And we know that immediately once we graph or sketch the vertex, we could draw the axis of symmetry equation. And you know what? Might as well state that. Axis of symmetry equation. That might be a question on the test, right? And we know that it's x equals the x value of your vertex, which in this case is negative 2. So that could also be a question on the test. And as we're sketching this, we need to look at the a value and understand that the negative is going to cause it to reflect over the x-axis, which means it's opening down. And the 3 itself causes a vertical stretch. So it is going to be slightly narrower. It's going to be narrower than the regular parabola. And it's going to be opening down. That is a really good sketch right there. I mean, it's not the best, but for sure, if you have multiple choice options, you could already identify which one it is, right? Anyway, why did I sketch this? To be able to answer what the range is. So what is the range? It's y values. And as you can see, it does not exist at y equals 1 or 2 or 3, right? It exists at the y value of -1. That's where it starts existing. And it's definitely below that -1. It's at -1 and below. So how do we state that in terms of an inequality? You're going to say y is less than or equal to -1. That is your range. So you see, I could give you an equation like this in vertex form, and I could ask you to find the vertex, or I could ask you to find the maximum or minimum value. I could ask you to state the axis of symmetry equation. I could ask you to state the domain, which is all real numbers, x equals all real numbers, or the range. Like I said, there's all kinds of questions that I could ask you when it comes to these parabolas, these quadratic equations. I could ask you to find the axis of symmetry, right? Now, this one's a little bit more challenging because it's not in vertex form, which means you can't immediately see what the vertex is. You actually have to use the vertex formula, x equals -b over 2 times a. And when you use the vertex formula, again, I say use parentheses. So I put negative parenthesis over 2 times parenthesis. Your a value is -2, your b value is 8, your c value is -13. There is no c value in this formula, so don't worry about the -13. But you do have the 8 that goes in there and the -2 that goes in there, giving us -8 over -4, giving us the x value of 2. All right, so if they were to ask for the vertex, then as of right now, you have the x value of 2, and you would still have to plug it in where? Into the original equation, right? The original equation, f of x is really just a y, and we have -2 parenthesis instead of x squared plus 8x, 8 parenthesis, minus 13. So if I really wanted the vertex, if the question was find the vertex, I would plug in the 2 right into those parentheses, and I would do the math, and it would give me the y value of my vertex, right? You know what, just for funsies, I might as well do that. So let me plug in the x value of 2 right there, and we're going to get 2 squared, that is 4. So I really have -2 times 4. We have 8 times 2, that's 16, and then minus 13. So when I do -2 times 4, that's -8, and then plus 16 minus 13. -8 plus 16, that's +8. 8 minus 13 is -5. That is a vertex y value. Now, did I have to find the entire vertex in order to state the axis of symmetry? The answer is no. The axis of symmetry is x equals the x value of your vertex. So technically, once you apply the formula, the vertex formula, and you get this answer 2, you're done. You could just say x equals 2, and that is your axis of symmetry equation, right? But again, I want to cover all possible questions that I could ask with regards to any type of function, whether it's standard form or vertex form. So anyway, right here, yeah, find the axis of symmetry equation, use a vertex formula, and once you get that x value, you could just say x equals that x value of the vertex, and you are done. Finding the y-intercept. Believe it or not, finding the y-intercept is ridiculously easy, especially when it comes to standard form equations, all right? So how do I find the y-intercept? Remember from the beginning part of Algebra 1, you set x equal to 0 and solve. So imagine you plugging in a 0 in place of x. That would cause things to become 0, right? 0 squared is 0, -3 times 0 is 0, so you have 0 plus, and then 2 times 0 is 0, and then bring down the -7. So at the end of it all, your y-intercept will be -7, right? In other words, your parabola will cross the y-axis at -7. I do believe that on the test, I gave the instructions to type it in as a coordinate with no spaces. So what is the coordinate for the y-intercept? It's going to be, well, we did set x equal to 0 to find it, so your x value must be 0, and the y value is, as we found, -7. So again, this is like a free point, guys. Why is that? Because whenever I ask you to find the y-intercept of a standard form quadratic trinomial, you plug in these zeros, and your c value is going to be the y-intercept value. Okay, so that's a really easy question. But then again, I could ask anything about this one. I could ask, what's the vertex? I could ask what's the minimum value or maximum value, all that good stuff. Let's also just take a standard form quadratic trinomial equation and let's graph it, yeah? Well, let's sketch it, okay? So, so we're gonna find the vertex, and the vertex is a coordinate, and we find the x value, that vertex, by using x equals negative b over 2 times a. And when we use that, we're going to use parentheses instead of the b and the a value, and we're going to plug in the b value of 4 and the a value of negative 2. So we have a 4 and a negative 2. What is our vertex x value? That is negative 4 over negative 4. So technically our vertex x value is x equals 1. And if they did ask for the axis of symmetry equation, that would be your axis of symmetry equation, x equals 1, but they're not. They just want us to graph. Okay. We still need the y value. Let's plug in the 1. You're going to have negative 2 times x squared plus 4 times x minus 3, plugging in the x value of 1 right there and doing the math. 1 squared is 1, so you really have negative 2 times 1, which is negative 2. Then 4 times 1 is 4. Bring down the minus 3. You will have negative 2 plus 4, that is 2. 2 minus 3 is negative 1. So the vertex y value is negative 1. Again, it says y equals, so y equals negative 1. Once you plug in the x, you found out that the y value is negative 1. So if we were graphing, you'd go to the vertex 1 on the x, negative 1 on the y, and you would put a dot right there. And then you would know that it opens down because it's negative, right? And it's kind of narrower. Another thing to do is to be like, well, it's really easy to find the y-intercept, right? The y-intercept. How do you do that? You set x equal to 0 and solve. That would produce the coordinate 0, comma, the c value, right? If you set your x's equal to 0, then this will be your answer, negative 3. So if you do go down to negative 3, man, you really have a very accurate, and of course map it over to the other side of your axis of symmetry, you will have a very accurate sketch of your graph. Okay? I hope this makes sense. You will for sure be able to identify the correct one if it's a multiple choice one. Anyway, let's move on. Graph this guy. All right, so how about this? Let's make it more realistic of what you're going to see on tomorrow's test. We have 3 options here. What do you say it is? Option A, option B, option C, or let's say D, none of these. So, by the way, if you had any of these that were opening up, you could eliminate those because this is negative, it has to open down. So the A value is 1/2. That causes a vertical compression, so it makes it a little wider than usual. So I'm thinking it might be either this wider one or that wider one, not this narrower one. But I do have an H value, and the H value is positive 3, right? You got to think opposite of what you see here. So it is technically none of these. Why is that? Because this guy, you got to think opposite. That's a positive 3. So the real graph should be 3 in the positive direction, 1, 2, 3 this way, and then opening up wide like that. So this is a better, that's like the actual sketch as opposed to the other ones, okay? I hope that makes sense. Notice that the K value, there is no K value that you're adding or subtracting at the very end, so there is no up or down shift. Okay, so I hope we understand the negative means that it opens down. The 1/2 means that it gets vertically compressed. The parabola gets wider. The minus 3 means it shifts 3 units to the right because you have to think opposite of what you see here. And the K value doesn't shift up or down, so that does mean that it's touching the x-axis. Okay. Let's actually describe the transformations from the original parent graph to this new graph that's in vertex form. So an original parent graph is y equals x squared, and if you think about y equals x squared, it's a regular U-shaped curve that opens up that has a vertex 0, 0. Now, as we read this vertex form equation, we should be able to describe the transformations. The very first thing you see right here is a minus sign. What does that mean? That it gets reflected over the x-axis. That's your first transformation. And then after that, you recognize that your actual a value is 2. Now, again, remember, 1, the a value of 1 is your parent graph. The a value of 2 causes a vertical stretch. And we write that down as our second transformation, a vertical stretch of 2. Of course, as the a value gets bigger, it gets stretched further and further. It gets narrower. It gets stretched further away from the x-axis. It gets narrower, right? If this would have been a fraction like 1/2, then you would have said vertically compressed by 1/2, okay, or a vertical compression of 1/2, right? But so if it's 2, 3, 4, 5, then that's a vertical stretch. If it's like 1/2 or 1/10, fraction less than 1, greater than 0, then that's a vertical compression. Okay. As for the final transformations that we read, so we already did the negative sign, a reflection over the x-axis, vertical stretch of 2. Then we have the h value of positive 3, and the k value of positive 5. Those are the shifts. So you would say your final transformations that it gets shifted 3 units to the right and 5 units up. So you got three changes, technically 4 if you count that last one as 2. 3 transformations from the original parent graph to this new one. So that's how I know that it's opening down, it's a little bit narrower, and the vertex is at positive 3, positive 5, right? Anyway, you're going to have to be able to describe those transformations from the original parent graph to the graph that you see here. Or not to the graph, but the equation that's stated there. What else? We have the more recent stuff, simplifying radicals. We always love taking the square root of a perfect square number, right? If you do not have a perfect square number, you have to rewrite it with multiplication to get a perfect square number. Not only that, whenever we do the square root of a negative, you could take that negative sign out and put an I out there, okay? That's a given that we learned recently. Whenever you have a negative, whenever you're taking the square root of a negative, you pull out that negative and it becomes the variable I, which means imaginary, which means not real. So what do we have so far? We have negative I, that's kind of like negative x, treat it like any other negative variable. And we do have the square root of 27 now, no longer negative 27. It's just a regular 27. It's still not a perfect square number, so I still need to rewrite it with multiplication to get a perfect square number. If you're not good with multiplication, just try to divide with the calculator. 27 divided by 4, it's not going to work. 24 divided by 9, it will work. It'll give you 3. So that's really a 9 times 3. And you could split the root, and you will get the answer 3, square root of 3. And, of course, we're going to bring down the negative I. So what I really have here is the variable negative I times 3 times the square root of 3. All we could do is rearrange it. If it were a negative x times 3, it'd be a negative 3x. But in this case, it's a negative 3i. And bring down the square root of 3, and that's it. That's the simplified radical. That's your answer, okay? Let's try another question. We have, obviously, solving quadratic equations, which, by the way, technically, if you knew the graph, like if you went to Desmos and actually graphed it, we do know the fact that the x-intercepts are the solutions. So if you graph it and you see that the parabola crosses the x-axis at -2 and +3, then your answers are -2 and +3, right? But of course, I want to encourage you I want to assess whether you know the quadratic formula or not. So I'm not going to give you nice x-intercepts like that, so you can't really cheat by going to Desmos and graphing and seeing what your x-intercepts are. If you do graph it on Desmos, well, first of all, you're going to have to rewrite it in standard form, plus 6x, setting it equal to 0. 3x squared plus 6x minus 1 equals 0. And now, technically, you could take the standard form quadratic trinomial and go to Desmos and graph it. But if you do that, you're going to see that it crosses at crazy irrational decimal values. Okay, those decimal values are the answers, But of course, the answers provided on the test will be in radical form, in exact form. What do I mean by that? You're going to have to use a quadratic formula. So we're going to identify A, B, and C, and we're going to use the quadratic formula x equals negative b plus or minus the square root of b squared minus 4 times A times C, all divided by 2 times A. And of course, when we use the quadratic formula, it would be great to rewrite it with parentheses. And let's plug in our b value of 6 right there and right there. Let's plug in our a value of 3 right there and right there. And let's plug in our c value of negative 1 right there. Of course, when we begin the quadratic formula, what's important is that discriminant value. The discriminant tells you a lot. It tells you if you actually have two answers, which means that the parabola would cross the x-axis at two locations. Or if it's negative, you don't have any answers. You end up with the imaginary values, which means that you don't have any real solutions. Or if your discriminant is 0, obviously the square root of 0 is 0, and it doesn't produce two different answers. If you add 0 and then go back and then subtract 0, it gives you the same answer. So the discriminant tells you if you end up with one real answer, two real answers, or no real answers. You always begin with the discriminant, and let's do that. Let's begin. 6 squared is 36. And then instead of a minus 4, I want to call it negative 4 times 3. That's a negative 12. And then negative 12 times negative 1, that's a positive 12. So the discriminant really is 48. Okay? The discriminant is 48. That goes inside the square root. So I'm going to rewrite my quadratic formula so far over here as negative 6 plus or minus the square root. We said that the discriminant is 48. So we know that the discriminant is positive. We're going to end up with two real answers. Now, they might be ugly answers. They will be ugly answers. It is over 6. Let's continue. From here, what we need to determine is, could this square root of 48 be simplified, right? Because if you're looking for that multiple choice answer, you're not going to find it. The fact is, the square root of 48, if I write it on the side, that will be able to be broken down to a perfect square number. So if you don't know, try 48 divided by 4. Yeah, it'll be 12, but I don't want to go with the first one that works. 4 times 12, it works, but let's try a higher perfect square number. Try 9. 48 divided by 9, it doesn't work. Try 16. 48 divided by 16, it does work. That's 16 times 3. That'll give you 48. So when you split the root, you're going to end up with 4 square root of 3. So let's understand this, that the square root of 48 could be rewritten as 4 square root of 3. So what we have here is negative 6 plus or minus 4 square root of 3, all divided by 6. Now, this is the correct answer, but if you look for that answer, you're not going to find it on the multiple choice options. You know why? Because you could still reduce. Now, what do I mean by reduce? There is a plus or minus right here, so you can't just like cancel out the 6's. What you have to do is reduce all 3 items by the same value. So the 6, the 4, and the 6 could all be reduced by, the answer is 2. So check this out. 6 divided by 2 is 3. 4 divided by 2 is 2. 6 divided by 2 is 3. We divided all of them by 2, and this is the final perfect exact answer. Negative 3, or answers, because it's technically 2 answers. The plus or minus means that there's 2 answers. But this is it, guys. This is what you're going to be selecting as your correct answer if this was the equation on tomorrow's test. Once again, roots, zeros, answers, x-intercepts, solutions all mean the same thing. So if you were to take the quadratic equation that we just solved, typed it on Desmos, you would see that it does cross the x-axis at 2 locations, but there would be crazy irrational decimal values, and that's why we use the quadratic formula, right? Again, the discriminant is the value that belongs inside the square root of the quadratic formula, b squared minus 4ac divided by 2a. Now, the discriminant tells you a lot. If this guy is a negative number, then you have no real answers, no real solutions, which means no real x-intercepts, right? you end up with imaginary. If you end up with the answer 0, then you end up with only one answer. I know that's kind of confusing. If you end up with 0, you only get one answer. That makes total sense, because if this is 0 and you do the square root of 0, if you add 0 and then go back and subtract 0, it's not going to produce two answers. It only gives you one answer. Okay. So once again, if you end up with a negative discriminant, there's no real solution. We know they're imaginary. If you end up with 0, there's only one real answer. And if you end up with something equaling a positive number, it doesn't matter if it's a perfect square number like 9 or a prime number like 13. If you end up with a 13 in here, even if it's ugly and you can't do the square root of it, you will be able to take this number, whatever it is, and add that crazy decimal, square root of 13, and then go back and take the same number and subtract that crazy decimal, square root of 13, and it will produce two different real answers. Okay, two real solutions. That means two real x-intercepts. It will cross the x-axis 2 times. So these are the 3 different situations that we deal with when it comes to discriminant values. Okay, so all of this will be on the test tomorrow. I hope this helps.